Is x plus 7 a factor of that? Oh no, we have to do synthetic division again? Yes, we do. And it's not going to be bad. It's not going to be bad, but what are we looking for? Well, if it's a factor, then we're going to get 0, which means it's an x-intercept, okay? That's the graphical interpretation of it, but our remainder is going to be 0. If this is a yes, we're going to get 0. So let's do this very quickly. Negative 7, 1, 7, negative 9, negative 63. There we go. We're going to bring that 1 down. 1, negative 7, 0, 0, negative 9, positive 63, 0. We got a remainder of 0, so is it a factor? I'm flipping the paper back over for just a moment. Factor theorem states that if a is a 0, then x minus a is a factor. Yes. So I'm going to just put, I'm going to put the word yes, and that's the answer to the question, but I do want to explain why. Because the remainder is 0. You don't have to write all this. I'm just explaining it so you can visualize it. Because the remainder is 0, x plus 7 is a factor of, I don't feel like writing that whole thing. I'll just say f of x. Terrible handwriting, okay? Is 6 a 0? Okay, do I need to make it negative 6? No. This was not x plus 6 or x minus 6. It was just 6. So, same process. There we go. 1, 7, negative 9, negative 63. Whatever I get here is going to tell me yes or no. If I get a 0, the answer is yes. If I get not 0, the answer is no. So, 1, 6, 13. Oh dear. I'm slightly embarrassed right now. It's been a long day. 60, 78. Wow. 69. And I give up. The answer is going to be no. 414, and then we subtract 63, and we have 351. That would be a big fat no. So, no. I'm just going to put the word no with the opposite of that reason. So there we go. No. 6 is not a 0 of f of x. Now, I'm not going to write the full reason, but here is the reason. 6 is not a 0 of f of x because that's not 0. Okay? Now it gets crazy. Given this function that has a k in it, and we know that x plus 1 is a factor, then what's the value of k? Well, let's just keep going. If it's a factor, then what's going to go right here? 0. There we go. Negative 1. But Mr. Reader, you have a k. Whatever, we'll get over it. 3. 0x squared. I almost wrote 0x squared. It's just 0. We'll put a 0 right there. But I hope you notice we don't have an x squared. 4. K. What are you going to do with your k? We'll deal with it. That's what we'll do. Here's what I want. That better be a 0. Because they told me it is a factor. This better be a 0. Okay? So, bring it down. 3. Negative 3. Negative 3. 3. 7. Negative 7. What's k minus 7? Well, k minus 7 is k minus 7. So in this little box right here, I have 0, but what it really is k minus 7. Boy, I left no room to write that, did I? So here goes. Right here in this little box, I wanted a 0. What did I really have? K minus 7. So what's k? Add 7. You get 7. Okay, let's do another. They're very similar. If you got this, keep moving without me. Given that, and the remainder when f of x is divided by x minus 10 is 3, then what's the value of k? So final answer is whatever k is. So 10, 1, k, negative 7. Okay, they told me that in this box, they don't want a 0, they want a 3. They said the remainder is 3. Okay, I'm putting it in the corner so I can make an equation out of it. 1 comes down. 1, 10, k plus 10. This is going to get sloppy. 10 times k plus 10. When I add these, it's equal to 3, but it is negative 7 plus 10 times, boy howdy, I didn't write a big enough square box, whatever. 10. I'm just going to make this so big, everybody can see it. All right, here goes. Let's start this thing over. This is 3, because they said so. It's equal to negative 7 plus, see, I'm adding these together, 10 times k plus 10. That goes here. Well, I need to solve that, so let's do it. 3 equals negative 7 plus 10 times k plus 10. Fine. I think we can move that 7 over. Add 7 to 3, we get 10. 10 times k plus 10. If you're ahead of me, you might have already distributed these. I'm not. I'm going to go crazy on it and divide by 10. It cancels those. 10 divided by 10 is 1. 1 equals k plus 10. I will subtract 10 from 1. I get negative 9. We are finished. I just marked through that next problem, but we're going to do it anyway. Same idea. I just want to show you one more, and we will be done with this lesson. Okay, given this function, and the remainder when f of x is divided by x plus 2, oh, negative 2. The remainder is 4, so 3, 0, k, and 4. 3, negative 6, 12, k plus 12, negative 2 times k plus 12. Go ahead and distribute that if you want. And when you add these together, what do you get? 4, because they said so. Well, when you add them together, what do you really get? You get 4 plus or minus 2 times k plus 12. So 4 plus negative 2 or 4 minus 2, either one. That is it. This is the equation that will help me find k. The earlier your k comes in this process, the more complicated it gets. But here goes. 4 equals 4 minus 2, k plus 12. We'll subtract 4. Oh, wow, we're about to get 0. 0 equals negative 2, k plus 12. We'll divide by negative 2. You can distribute if you want. I choose not to. 0 equals k plus 12. We will subtract 12, and we get, well, negative 12. We have found k. There we go. We've used the remainder theorem in the earlier part of the notes, because if we get 0 as a remainder, we know it's a factor or a root. There we go.